9.6, volume and moles. So we looked at volume and pressure, that was Boyle's law, and then we looked at temperature and volume, that was Charles's law, and then we looked at temperature and pressure, and that was Gay-Lussac's law. Now we're down to volume and moles. So the volume and number of moles are going to be directly proportional. If the number of moles increases, so does the volume. So and that just makes sense if you've got more. If the number of moles increases, the volume increases. Now, assuming that the pressure and temperature are constant. So let's look at our first problem. Here we've got 0.75 moles of helium gas, and that is in a volume of 1.5 liters. What will the volume be if now we have 1.2 moles of gas? So we've got our equation up here. We've got volume 1 over number of moles 1 equal to volume 2 divided by number of moles 2. Let's put some numbers behind these. These are our first values, and these are our second values. Make sure we have them set up so they go together. Okay, we do not have the second volume, so if we multiply both sides by the number of moles 2, we'll be able to cancel out, get a different color, so cancel out N2, and that leaves us with V2 by itself. I'm going to rewrite this. V2 is going to be equal to N2 V1 divided by N1. And N2 is 1.2 moles. V1 is 1.5 liters. And N1 was 0.75 moles. If we look at our units first, we'll see that we've got moles on the top and moles on the bottom, so those will cancel, and we'll get our answer, 2.4 liters. Now, frequently, when we're dealing with gases, we measure them under STP. This is standard pressure and temperature. And the standard pressure and temperature are at 0 degrees C and 1 atmosphere. So at standard temperature and pressure, a mole of gas will occupy 22.4 liters. We can use that to solve problems. We can say that 1 mole at standard temperature and pressure is equal to 22.4 liters. That's an equality. So we can use that to convert. So what volume is occupied by 2.75 moles of nitrogen gas at STP? So we have 2.75 moles, and we would like to convert that into liters, and we can use this equality to do that. We're going to put the 1 mole in the bottom and our 22.4 liters in the top. So moles is going to cancel. Moles in the top and moles in the bottom. Take 2.75, multiply it by this molar mass, and we will get 61.6 liters. So what is the volume at STP of 400 grams? Okay, so this is a little different problem than what we've done in the past. We've been talking so far in moles, but they've given us this in grams. So we're going to start with 4 grams of methane. Methane. We're going to convert that into moles. We don't know how many. And then we're going to convert that into a volume. Or it'll be in liters. Okay, to make this first conversion, we'll need to know the molar mass of our methane, our CH4. And we can look that up. Carbon is 12, and each of the hydrogens is going to be about 4. So we get 16. I'm going to write that in a different color. So we've got 1 mole of our methane is going to weigh 16.0 grams. What I did is I took the carbon, weighed 12, and we had 4 hydrogens that each were 1, and that equals 16. All right, let's get a different color. And we'll do our second conversion. We're going to be going from moles to liters. And 1 mole at STP will be 22.4 liters. So now we've got a 2 conversions to do that will get us to volume. So we're going to start with the number in the problem, which they gave us that we had 4.00 grams of methane. Let's see if I can draw this line reasonably straight. There we go. We'll use our first conversion. We're wanting to get rid of grams, so we'll put our 16.0 grams on the bottom, and we'll put our 1 mole of methane in the top, CH4. Then we're ready to do our second conversion. Now we want to get rid of moles, so I'm going to put the moles in the bottom and the 22.4 liters in the top. Now to do the math, I'll take 4, multiply by 1, divide by 16, multiply by 22.4, divide by 1, and I will get 5.6. Then I need to look at my units. So let's cancel some units out here. We have grams here and grams there, so we'll get rid of grams. Then we can get rid of moles because we've got moles there and we've got moles here. So we're left with liters for our units. So let's make it match. There we go.